Okay, good morning. Um, I'm going to try to tell a story in 10 minutes, uh, try to sum up my year and the work that I'm doing. So, I'm working on an integrated modeling framework of the minerals beneficiation chain. And as the year has progressed, I started working on this in January. As the year has progressed, it has evolved. As I gain new understanding, new knowledge, and new thinking, and I think there are two events that have been very important in formulating my thinking. And one of them was attending the mineral law in Africa, Henry, which really revealed to me the complexities of the problem. And the other one was the strategic engagement course that we did at the GSB, where we learned about wicked problems and how the mining industry and stakeholder engagement, how this is complicated, it's very complex, and there's no one solution to fit it all. So what we are trying to do here is to develop a framework that is a tool that can aid in some of the decision-making processes. So this is in line with the objectives of our group, and named chief among them the third objective, where we try to produce an integrated modeling framework that incorporates all unit operations. So this is starting from the technical, where we try to understand how our mine, our operations, our mineral processing operations operate, and try to then quantify some of the environmental impacts, the social impacts, based on a technical process model. So just to refresh on what sustainability in our context, in the context is we're trying to maximize resource efficiency by balancing out the social, economic, and environmental pools. So we don't want to end up where we are leaning too much on the environmental and neglecting the social and the economic aspects. I always joke that the most environmentally friendly way that you could do mining is not to mine at all. That way, there's no damage to any environment. But you do realize, like, especially here in Africa, we do need mining to be the driver of economic change. So, as much as mining might seem undesirable and might have effects that are visually unappetizing to most people, it is an essential part of our economy, and therefore there should be a drive towards leveraging mining to be the driver that kickstarts other sectors of the economy, so that we can move on 50 years from now into a more transformed economy that's not heavily dependent on natural resources. So to this days comes the context of circular economy, where we are now moving from cradle to grave approach in terms of how we utilize our resources to more cradle to cradle thinking. And this has been driven mostly by the European countries, which really take this seriously. And they've made sure that even the policies towards recycling, reuse of raw materials is more emphasized in their policies. And then that leaves the question, so if the whole world is going to be recycling metals, where is our future in terms of Africa? Where are we going to stand? Because we supply the natural ores, the natural materials, and so that means there will be a reduced demand in terms of our metals and minerals, and then therefore, so we need to also consider this aspect. But when you look at the circular economy, what's evident is that irregardless of how much there might be recycling that is going to take place with urban mines rising up, where people are getting metals and extracting metals from electronic waste. our raw materials, our natural resources is still going to be required in the cycle, because the more you recycle, the more you recycle, for example, if it's steel, it lowers the quality of the product. So you will still need to put in some virgin material. So there is a place for Africa in terms of our mineral resources and how we can contribute going forward. So I'm starting at mineral processing operations, where for the start I'm focusing on the concentrator circuit, and leading, which feeds on to other processes. So it could be concentration via flotation, hydrometallurgy, and pyrometallurgy, where you obtain the final product, which is a metal. And I define beneficiation as any stage that adds value to our mineral or metals. So the objectives that I have is to produce a framework that will allow us to be able to integrate the comminution with hydrometallurgy, with flotation, and also go further to pyrometallurgy. So where we can take an ore body and simulate the different products that you can get from it, looking at and also be able to do scenario analysis where we consider different processing routes, and also be able to quantify the impacts of each of those scenarios on the environment and on sustainability, which is the environment, the economy, and the social aspects. So this is what the framework will look like. So it will have chief among its ore characterization, because most of the environmental impacts that are observed downstream are due to the characteristic of the ore. So we need to understand what type of minerals are in the ore, what type of elements, and what is the potential impacts of those elements if they end up in the tailings, or if they end up being dumped in nature. Then among them is one of the stages as well is the process modeling, and this is really important, and it's where I've been spending most of my time working on, because if you need to come up with a model that is as realistic as possible, that considers all aspects that can potentially be observed in an operating mine. That includes all the wastewater streams, all the elements or that report to the water stream. So that means effluent quality, dust. So you're looking at a very complex model that tries to incorporate all these things, and it relies on existing knowledge. So we're not trying to reinvent the wheel and come up with a new simulator. So we've looked around and tried to find out what is the most comprehensive packages that are around that can allow us to integrate to model all the different circuits from mineral processing up to pyrometallurgy, to link them together, and also to allow us to track the different elements or minerals that we want to track, so that we can be able to assess the impacts that they have on the environment. Because we understand that if you've got poor models here, it's junk in, junk out. So whatever you get, it's not going to make any sense. So then the next challenge that we have is then how do we measure how do we come up with these metrics that measure the environmental impacts? And some of the work is being done, and Jenny has been doing similar work with acid rock drainage potentials. So we tried to devise new methods of measuring energy usage, effluent quality, the potential impacts on the environment, and these quantifiable metrics will allow us to standardize. That means that if we are able to assess different process flow sheets and compare them in terms of how they perform on the environment. And then we've taken a more traditional approach where we do life cycle assessment, and in some cases where We have different criteria that we are considering. We will apply multi-criteria decision analysis. And when these tools are all put together, combined together, it allows for decision makers to interpret what the framework is giving out, the outputs, and allows them to make decisions. And it's hoped that these decisions will allow them to optimize the techno-social economic aspects that make up sustainability. So we are using our simulator, the stages of or how we develop the simulator, and I think some of the speakers that will follow on me are some of my students who are working on different parts of the problem. All characterization, so this is mineralogy, so we understand that mineralogy, and especially process mineralogy, is the key to this framework. So we need to get more applications. So how do we formulate our process flow sheets or our process models so that they incorporate all variability? So because we understand that as you mine your ore body, there are different areas and they all will change. So you need a simulation that's able to capture those changes that can happen and be able to highlight these changes in terms of the environmental impacts. So so stream characterization is very important, knowing your stream composition, doing mass flow, water balances, and energy balances, and also then followed by process modeling, which has the potential to, where we can also apply process optimization. One thing that I've understood, which is highlighted and I've been thinking about a lot, is how this framework and this process can not only be driven by the mining industry. Of course, the mining industry has more to benefit from sustainable mining, but it's us, the consumers, who can be the drivers to make that change that is required to transform the industry. So we need to be more conscious about how we use the resources that we use, so the products that we use. Do we think that the guys who are making these products are considering how the product is going to be disposed? And then if we start thinking about these questions, then we can challenge them. And then through that, because that activism can lead to a steep change. Because if you understand how most mining operations, the economic aspect is what's important to them. If you read on the business sections of the news, it's all about money, increasing shareholder value. But us as consumers can play an important part in getting this and in getting sustainable mining in being incorporated in the current activities. So that's what our tools tries to do, is then try to aid, to help policymakers, to help mining companies, to help consumers understand the complexities of the minerals and metals that they are using. Where do they come from? And what are some of these social and environmental impacts that arise from trying to extract those resources? So like I said, we use life cycle assessment, and this just explains the general steps that are involved in doing life cycle assessment: goal and scope definition, inventory analysis, impact assessment. And then where we have multi-criteria, we want to determine which criteria is most significant, or determine a decision, or we use multi-criteria analysis, where we select criteria, we weight the criteria, we evaluate, and we aggregate the results. This allows us to compare between different scenarios and to see which one is the best. So the benefits for the mining companies is improved and to optimize process performance, improve the quality of solid and effluent streams, and this is a cost-effective tool for simultaneous techno-economic environmental analysis of processing flow sheets. The challenges: the models that capture effects of all variability. So as we work on this framework, we are also working on these technical aspects. how do we develop better models that can capture all variability? The costs associated with collecting mineralogical data, and you hear from Site, she will talk about element to mineral conversion, which is one way of trying to lower those costs by getting quality, sufficient mineral information of your streams from your elemental analysis. And we've started developing metrics for measuring environmental and social impacts, and determining the environmental footprint of processing different ores. This is a challenge, and this is what we've started to do, and we hope with this framework we'll be able then to come up with the environmental footprint of processing different ores, and also determine how we can make this mining more sustainable. Thank you.
Thanks, Ed.